Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. ଏଥିରେ ମୁଁ ଅଲରେଡ଼ି ପ୍ଲସ୍ ଟୁ ସେକେଣ୍ଡ ଇୟର ସିଲାବସ୍ କମ୍ପ୍ଲିଟ୍ କରିସାରିଛି। ଏବେ ମୁଁ ପ୍ଲସ୍ ଥ୍ରୀ CBCS ଫିଜିକ୍ସ ଅନର୍ସ GE ଆଉ MSc ଫିଜିକ୍ସ ଅନଲାଇନ୍ କ୍ଲାसेसର ଭିଡ଼ିଓଜ୍ ଅପଲୋଡ଼ କରୁଛି। ଯଦି ଭଲ ଲାଗିଲା ତାହେଲେ ଭିଡ଼ିଓଜକୁ ଲାଇକ୍ କରିଦେବ ଆଉ ଚ୍ୟାନେଲକୁ ସବସ୍କ୍ରାଇବ୍ କରିଦେବ। ୟୁ କ୍ୟାନ୍ ସେୟାର ଇଟ୍ ୱିଥ୍ ୟୋର ଫ୍ରେଣ୍ଡସ୍ ଅଲସୋ, ଇଟ୍ସ କମ୍ପ୍ଲିଟଲି ଫ୍ରି ଅଫ୍ କଷ୍ଟ। लेटेस्ट वीडियो नोटिफिकेशन ପାଇଁ ବେଲ୍ ଆଇକନ୍କୁ ଏଠି ଅଲ୍ରେ ସେଟ୍ କରିଦେବ। ତାପରେ ଭିଡ଼ିଓଜର କ୍ଲାରିଟି ବଢ଼ାଇବା ପାଇଁ ଗो ଟୁ ସେଟିଂସ୍, କ୍ୱାଲିଟି, एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन। सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स। तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो। ओके, थैंक यू। हेलो स्टूडेंट्स, आज टॉपिक रे हमें न्यूक्लियर क्रॉस सेक्शन ए विषय पढ़िबा। सो जेतेबेले हमें गोटे टार्गेट न्यूक्लियस नौचु आउ ता सहित बम्बार्डिंग करूचु इंसिडेंट बीम ऑफ पार्टिकल्स। सो तापर कोन हबो नहीं, जदि गोटे न्यूक्लिया में नहीं गला टार्गेट न्यूक्लिया जेमति कहली ऑफ अ स्पेसिमेन आउ इंसिडेंट कोलिमेटेड बीम ऑफ पार्टिकल्स हमें नौचु। ओके, then they interact with these through the processes like your scattering, absorption and or reaction, and thereby becoming attenuated in intensity or energy or both. Okay, so ये through reaction cross section जो देखिबा, it depends upon the incident particle energy and the height and the thickness of the potential energy barrier rather than upon the geometrical area of the target nuclei. Okay, now each nucleus is associated with the area jaku ki hame kahiba sigma, and it is perpendicular to the incident beam such that if the center of a bombarding particle imprints upon any part of such an area then the reaction will occur. Kintu jodi center bombarding particle ro outside this area rohuchi tale no reaction will take place. Okay, so this effective area of the nucleus is called as the nuclear cross section. याकू ही हमें कहबा nuclear cross section. That means it is a quantity having the dimension of area, right? So for a particular reaction nuclear cross section ro value alga alga hi pare. Okay, so it is a measure of the probability of a particular reaction. Okay, and the probability of a nuclear reaction can be defined in terms of the number of particles which are emitted or of the nuclei undergoing transmutation for a specified number of incident particles. Thus, the probability of occurrence of a particular nuclear reaction is described by the effective cross section of a nucleus for that process. Okay, a cross section को हमें also define करी परिबा like number 1, the probability that an event may occur when a single nucleus is exposed to a beam of particles of the total flux 1 particle per unit area. Our second कहूची the probability that an event may occur when a single particle is shot perpendicularly at a target consisting of 1 nucleus per unit area. So although the reaction cross section bears no direct or simple relationship with a geometrical nuclear cross section जोटा कि हमें कहबा pi r square. Okay, so एठी कि हमें r नौचु nuclear radius, so एटा आसीगला गोटे सर्किल area, so pi r square. Nevertheless, for most nuclear interactions it agrees with it as far as the orders of magnitude is concerned, and generally it falls within the range of 10 to the power minus 28 to 10 to the power minus 27 meter square. Okay, so it is a very small value because power जब देखो तमे एठी 10 रो होची minus 27 by minus 28, and due to this small value it has been found convenient to use a particular unit जाकु कहबा में bar, which is equal to 10 to the power minus 28 meter square, and it is used for measurement of this nuclear cross section. Okay, नाउ मूविंग फर्दर केते केते प्रकार क्रॉस सेक्शन रोची प्रथमटा हला partial cross section. Okay, so the total nuclear cross section is the effective area which is possessed by a nucleus for removing the incident particles from a collimated beam by all possible processes. Okay, and this can be written as a sum of several partial cross section. Okay, and they represent the contribution of various distinct independent processes which can remove particles from the incident beam. So ଆମେ ଲେଖିପାରିବା ଏଠି sigma. Okay, sigma is used for the cross section. Okay, sigma t equal to sigma sc plus sigma r. Okay, it is sigma t মানে t for total, so it is the total cross section. SC means এটা হଉଛି ତମର scattering ଦ୍ୱାରା ଯୋଉ cross section ହଉଛି ବା ୟାକୁ ଆମେ elastic scattering cross section ବି କହିପାରିବା। ଆଉ ରହିଲା 3 ନମ୍ବରରେ sigma r. R stands for reaction. Okay, ଏଥିରେ ବହିରେ RE ବି ଲେଖା ହେଇଥାଏ। Okay, so এটা reaction cross section କେତେଟା ଜାଗାରେ ଏଠି absorption ବି ଲେଖା ହେଇଥାଏ। Okay, so scattering cross section ଯଦି କହିବା it can be classified as due to elastic scattering and inelastic scattering ବି ଏଠି ଆସିପାରିବ। Okay, thus we get sigma SC equal to sigma elastic plus sigma inelastic, and these partial cross section can still be subdivided like this. Okay, so in the case of elastic cross section, separate partial cross section cannot be written because of the possibility of interference between them. Okay, elastic re ame separate likhi pariba nahi. On the other hand, in case of your all inelastic scattering processes, as they are not coherent, that means they are incoherent, so their cross section are additive, we can add them. So sigma inelastic equal to sigma 1 plus 2 plus 3 and so on. So similarly, जो our second quantity thila sigma r, the partial cross section for reaction may be subdivided into component parts which are associated with various possible nuclear reaction. So likewise sigma r equal to sigma suppose dash, sigma double dash, triple dash and so on. Okay, so এটা গলা partial cross section. Next one is the differential cross section. Okay, so the distribution in angle of the emitted particles in a nuclear reaction can be described in terms of a cross section which is a function of the angular coordinates in the problem. So here the cross section actually এটা actually defined করছি a distribution of emitted particles with respect to the solid angle ଗୋଟେ ଆସିଗଲା ଏଠି 3 dimensional solid angle ଯାହାକୁ କି ଆମେ ଏଇ ଯୋଉ definition ଟା ଆସିଲା it is nothing but the differential cross section and we can denote it by d sigma by d ohm. Okay, so sigma ଥିଲା ତମର total cross section, ୟାକୁ differentiate କରିବା with respect to solid angle ताहले हमें पाइबा d sigma by d ohm, which is the differential cross section. Now how you determine this cross section? Determination of cross section. Experimental values of sigma can be obtained by the measurement of attenuation of an incident beam in a known thickness of the material. এটা experimentally बाहर करि परिबो. Suppose if a monoenergetic beam consisting of I number of particles per unit time distributed uniformly over an area A is allowed to pass through a thin sheet of target material having thickness suppose delta x and having n number of nuclei per unit volume, then we have the available nuclear target area which is the product of the cross section per target nucleus, that is sigma, and the number of target nuclei lying within the area A. Okay, so here ଆମେ assume କରିବା ଯେ the target is thin enough so that there is no overlapping of the nuclei and thus every nucleus presents its entire effective cross section to the incident beam. Okay, कौनसी भी न्यूक्लिय न्यूक्लिय ମଧ୍ୟରେ overlapping ହେଇନି so that प्रत्येक न्यूक्लियस द्वारा effective cross section aadku contribution aschi. Okay, hence the probability for one incoming particle to hit the target nucleus is equal to the target nucleus area, that is sigma Na delta x divided by the total target area, that is A, right? So if the nuclear reaction produces capital N light product particles per unit time, then the reaction probability is defined as the ratio, that is N by I. Hence we can have N by I equal to sigma Na delta x by A, right? Or ଏଥିରୁ ପାଇଗଲା ଆମେ sigma equal to this much N by I by A into Na delta x. Hence the nuclear cross section can be defined as the number of light product particles per unit time per unit incident flux, जोटा एठी क्वांटिटी आम मैथमेटिकली पाइछु ताकू इन वर्ड्स रे कहूछु, per unit flux and per the target nucleus. So if the bombarding particles is producing a variety of light reaction products, like suppose n1 n2 dot 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 per unit time, then the total cross section accordingly will be sigma t equal to एठी ऊपरे एटा केवल चेंज हो n1 plus n2 plus up to ଯେତେ ଥର ଆସୁଛି ଏଠି reaction products. So it is convenient to define also a partial cross section for the suppose ith process. So sigma I equal to ni divided by तଳ तो same रहुची, so we can write the total cross section sigma t equal to summation over I sigma I. Okay, so if the incident flux, that is the beam intensity is suppose I0, and the flux after penetrating a distance x is equal to I, then it will become I minus di after a further penetration. Okay, suppose through a distance, very small distance dx, because intensity kami jauchi. So this reduction in the flux is caused by the various collision events which are occurred within this distance, which is dx. So ଏଠି reduction होची, ତେଣୁକରି minus symbol ଆମେ ଦେଲା minus di କୁ ଲେଖିପାରିବା equal to n, which is equal to small n sigma dxi, or एठी हमें पाउचु minus di by I equal to sigma n dx. So this expression contains the product of sigma, which is the cross section per nucleus, or the microscopic cross section, and small n कौन, the number of nuclei per unit volume. So the product is called as the macroscopic cross section and is denoted by summation symbol. Okay, so summation आम नहीं केमती लिखि परिबा minus di by I equal to summation over dx, or I equal to एठी जदि आम इंटीग्रेशन करिकी याकू बाहर करिबा ताले I equal to I0 exponential of minus summation x. Okay, so this shows that there is an exponential weakening in the particle flux upon the passage through the thick target. Okay, and the quantity here summation jota ame nouchu, which is equal to n sigma, is called as the linear attenuation coefficient of the beam, and the ratio I by I0 yaku koiba ame transmission of the slab, which is the thick target. Okay, now here the attenuation that a beam experiences as it goes through a target may take the form of a reduction in the actual number of particles traversing the target without the change in the energy, suppose as in the case of your gamma ray beam. Okay, or a diminution. Okay, diminution in the mean energy of the particles due to the scattering, absorption, or ionization process. So the reaction rate, or the number of reaction per second, will be given by capital R, which is equal to I0 minus I, so that I रो value हमें put कर देले एतिकी बाहरी गला. Okay, and if small x, which is a very small quantity, okay, or the target is, we can say it is a thin target, then we can simply write R equal to I0 n sigma x. एटी exponential जो quantity को हमें तार derivation करिकी फर्स्ट टर्म को खाली रिटर्न कर रखुछु, हायर ऑर्डर टर्म्स को हमें नेग्लेक्ट कर देला, राइट. So the experimental arrangements consist of a source and a detector between which can be placed a thin slab of target of the experimental material, and if I0 is the particle intensity reaching the detector in the absence of the absorbing material, and I is the value when the target of thickness is d containing n atoms per unit volume is present, then the total cross section sigma याको आमे calculate करि परिबा by using the expression sigma equal to delta I by I0, which is multiplied with 1 by nd. Okay, so this is equal to diminution in incident wave intensity divided by incident intensity into the quantity, that is target nuclei per centimeter square. So in terms of beam power mane q0 by t ए हिसाब रे हमें लिखिला. The cross section may be defined as sigma equal to delta q by t divided by delta q by t divided by q0 by t whole into 1 by nd, which is diminution in energy flux divided by incident energy flux into target nuclei per centimeter square. Okay, so in many nuclear reaction the light product particles are not produced in an isotropic manner. तेणुक आम कौन करवा, आम गोटे डिफाइन करवा डिफरेंशियल क्रॉस सेक्शन जोटा आम आगु देखुला डी सिग्मा बाय डी ओम इन टर्म्स ऑफ द नंबर ऑफ लाइट प्रोडक्ट्स व्हिच इज dn emitted per unit time in a small solid angle d ohm at small angle theta with the direction of incident beam. As you can see in the figure, एटा आसुची तमर जो solid angle टा, right, this solid angle which is d ohm dn एपटे आसुची. okay, dn माने number of light products, एटा angle create करूची देखो एठी theta. okay, this angle is theta and ए डायरेक्शन टा तमरो incident beam direction. okay, आउ एटा आसुची तमरो ए होची एरिया क्रॉस सेक्शन, राइट. ताले एबे ऊपर जो इक्वेशन 29 आमे पाउथला सेथिरो आमे लिखि परिबा 1 by I dn by d ohm equal to this much. okay, thus the differential cross section per target nuclei equal to sigma theta equal to d sigma by d ohm, which will be equal to dn by d ohm divided by I by a whole into n a delta x. एटी राइट साइड फिगर रे भी देखो एई जो एरिया यही एरिया को आमे एतिकी नहीं परिबा, आ एठी प्रत्येक जो डॉट डॉट देखा जाउची these are nothing but the total cross section. okay, so एतिकी एरिया तमरो नहीं जाउची न्यूक्लियस रो क्रॉस सेक्शन टोटल एरिया रे एतिकी आछी. okay, so एटा हमें पाउचू सिग्मा थीटा. नाउ द टोटल क्रॉस सेक्शन सिग्मा इज सिंपली द इंटीग्रेशन of this differential cross section over all space, सब स्पेस पई जदी हम नहीं जिबा हला ताले it is equal to the integration d sigma by d ohm into d ohm. ताले एठी d ohm जो सॉलिड एंगल आछी दुईटा एंगल रो एठी कांसेप्ट आसीबो, गोटे हला थीटा रो आ गोटे हला फाई रो. ताले sin थीटा d फाई आसी गला. ओके, अकॉर्डिंगली रेंज जदि आमे देखिबा बा लिमिट देखिबा गोटे रहउची 0 to 2 पाए, गोटे रो 0 to पाए. ताले एतिकी आमे पाउचू आ सिग्मा थीटा रो वैल्यू जानी कि जो हमर इंटीग्रेशन को आगु को हमें एग्जीक्यूट करबा को पड़िबो. इन केस ऑफ सपोज ए स्पेशल केस गोटे आइसोट्रोपिक एमिशन ऑफ रेडिएशन नबा ताले एठी आसी जिवो सिग्मा इक्वल टू 4 पाए सिग्मा थीटा. आइसोट्रोपिक जदि होउची ओके so the curve representing the variation of differential cross section that is d sigma by d ohm with the angle theta, the angle between the direction of beam, okay, the direction of beam and that of the detector will give you the angular distribution of the ejecting particles. Okay, এই curve ରୁ ଆମେ ପାଇପାରିବା okay so this is all about the nuclear cross section ଯେଉଁଥିରେ କି ଆମେ ଆଜି ୟାର basics introduction part ଟା ଦେଖିଲା।
Thank you.